Hello and welcome to today's LeetCode video. Today we're going to be doing 1C1 palindrome partitioning. Given a string S, we want to partition S such that every single substring with the partition is a palindrome, and we want to return all possible palindrome partitioning. So we're given this example here where you have S and what you want to produce as a response is a series of partitions such that every single one is a palindrome, and that's valid over here. You have A, and B. Imagine you split this in here and here. We have that as a final result, and we can also split it one down over here and have this one as a final result. And for the second one, you only have one option, which returns just the same thing, well, like itself. So one way that I'm gonna think of doing this is by using backtracking. And what I'm going to do is I'm going to do backtracking, checking to see at every single point whether or not the current item in the string is a palindrome. So let's say like we start off with AAB. We start off with AAB over here. Oops, that was an accident. We start off with A and B, and we know that from here we can either select A, or we can either select AAB and have that be our first one. Now, for this one, if we choose this one, we have nothing left, so we can't keep moving on forward. For this one, you are able to select B, so you can move that forward, and then for A, you still have A and B, so you can have that forward as well. Another thing to keep in mind is that you have to have all possible strings be palindromes. And in this case, this is a palindrome, this is a palindrome, this is not a palindrome, so you can't continue going on with it. So if we move further down for, let's say we have A, we can go with another A as well. And then at that point, we can do AB. AB isn't a palindrome, so that gets ruled out. And then you have A instead, or like a B as a final value here. Since all of these are valid palindromes, we want to keep track of the values which we need here by having some sort of accumulator which does so. And then for this one, we also want to end it once you have nothing left. So for the AA as well, we want to check to see what happens at the end by adding a B, because that's the only available one left. And for this one, this can also end here when you have nothing left. And yeah, so that's how we're going to arrive to our final solution. So in short, what I'm going to do is do a backtrack on every single on the string, like selecting every single possible combination and only moving forward if we can tell that it's a palindrome. So I'll go ahead and begin coding this up now. First thing what we want to do is have a result or a current, right? We have our current, which contains what's currently available as we're traversing down. And we also want the result one because we want to append that and return that at the very end. Return res. And then we also want a def backtrack. And we can call backtrack starting off, let's say, yeah, like with the very first string. So we can go ahead and let's say we'll start it off at, or let's treat it in terms of indexes, where you have this, it's starting at the 0th index. Now, after this, we can do a while loop. So while the you want to do for every, so for this one, you want to check to see while we want to do if, you want to do a check first to see if it's ended. So if the index, right, if the index is greater or equal to the length of the string, then you know that you've exceeded the limit and you want to stop here. And you, I guess at this point, you would also want to append the value that you've generated up at the very end. So you can do cur or res.appends cur to the as part of the final result. Now, next thing you want to do is for every single element, right? So we can have let's say like a right pointer for our in range length of string. You want to go ahead and do a backtracking on it. So you can backtrack, and then as part of the backtrack, you can go ahead and say what you've used at a given point already. So at this point, we've already used the very first element. So you want to move it forward by I plus 1 and only do it for the you only want to use the elements which are past a given index. Now, we also want to, as we move forward, you want to you want to res.append the cur, and then you also want to add the current one to the cur, right? The current element. So you can go ahead and do cur dot appends, and you can append the string from the left pointer starting from, or I guess the ith pointer. To make this more simple, we can simply call this L, and we can go from the left pointer up until the right pointer plus 1. So it'll grab every single character from the left to the right and then append that to the current one. So for our first one, it's just going to append A. For our second one, it's going to append AA, and for our third one, it's going to append AAB. From here, what we're going to want to do is do a backtrack on it on I plus 1, and then you want to you want to append the cur dot. Okay, append the cur. You want to make this a copy, because if we're appending the same reference to the cur array at every single given point, it won't work. So you have to create a copy as you do this. So it'll be a new instance that won't be modified as the cur one is modified. Another thing that we have to do, back to our original problem, we append up until the given point, the character up until the given point, and you call backtrack on I plus 1. And then at the very end, you don't want the cur to affect the next iteration of the sequence. So you want to do cur.pop to pop what you've just added out of the thing.
30 minutes? I think 20 is too short.
So at the very end of this one, what we can go ahead and do...
I'm not gonna lie, I'm kind of cooked. I can't solve it.
Wait, sorry.
I got an output, but it's psychotic.
So does it work or no?
No.
Okay. Sorry, I was on a call. So back to what we were saying. You go ahead and pop this from the backtrack. Yeah, you pop it from the current array, and then you keep calling it backward. Oh, and before you do this, you actually have to check to see you only want to do this if it's a palindrome. So you can do an if statement to see. We can call self.isPalindrome. We can implement this later, and we can check to see if the string from the left to the right plus 1 is a palindrome. If that's so, then we're going to do this entire operation over here. Now, we'll go ahead and implement that now. So we'll have def is palindrome, where we have self and then our current string, our current string that we pass in as a parameter. Now, for this, we can just do it the regular way. We have a left pointer and a right pointer, which is equal to 0, and then we have the length of the s minus 1, and then while left is less than or equal to the right, what we can go ahead and do is check to see if L not equal to the right, then we can go ahead and return false. Otherwise, we want to keep incrementing the left and the right pointer, incrementing and decrementing the right pointer. So left and right equals L plus 1, L or minus 1. And then from here, if that does it everything successfully, we can go ahead and then return true. So yeah, we go ahead, is palindrome, check if see if it's valid, and if it's true, then we append it, we backtrack, and we keep doing it. Otherwise, we yeah, keep going, and then finally at the very end we append the result. Okay, go ahead and run this. There could be a couple syntax errors, so we'll try to see what gets. Oh yeah, so we go backtrack on the left plus 1 because I renamed it to make it more clear. Okay, memory limit exceeded. So you're appending it. Oh, we have to, let's see. Is palindrome. So it's not actually ending. So, oh, we have to do a while loop for this one. So while. Oh, okay, I see what's going on. Okay. Actually, let's think about this. We start off with the L being greater. If it's greater or equal to the length of the string, right? So if it's equal to the length of the string, it's 3. Then you want to backtrack, yeah. And then at the very end, you want to pop it. We start off at the 0 at the left pointer being at index 0. We check to see whether or not it's greater. If not, then we append. And then, oh, I think at the end of this, we want to go ahead and do a break. Yeah. We want to break out of the function. So, or actually, we can just return nothing at the very end here. Because we don't want it to keep going on infinitely. Okay. Oh, I see. This should be S left, and this should be S right. You're not actually doing the comparison with the pointers. You have to do with the just treat it as an index. And then we can go ahead and remove this one again. Okay. Oh, and you also want this to only start from the left to the length of the string, because everything else has already been traversed through. Then we have A, B, we have AA, and then AB. Otherwise, you return true. If I is less than or equal, if L is less than or equal to length, you append, then you check to see if it's a palindrome. Then you add it and you check to see. Yeah. For some reason you were appending A still. when we don't want that to happen. Oh, we need this to be the length of the string. Well, this can't be the length of the string, actually. This needs to be the length. Oh, it needs to be the length of the inner string. So actually, it does work. Like it should work still. Oh, I see. You actually need to backtrack it with starting at r+1 because that's what you want to go from. You want to go from the right. And then from the right, that's what you have that's available. Everything to the left has already been taken. So that's why you're adding an extra character on top of it. Okay, nice. Figured out the issue. It turns out my else statement from before is what was causing it. And it was because it wouldn't in the case where it would try to grab the EFE, it would stop because it would just return before then. So that's why it wasn't working, and that's why the other test cases weren't working as well. If you go ahead and run this, the test cases should be passing now. Okay, great. And the time complexity of this one is O of 2 to the power of n because it's a backtracking solution and we're attempting every single possible combination. Okay, thank you for watching.